13,000 people die on our nation's highway every year in what are called runoff road crashes. These accidents involve a single vehicle departing the road, typically because the driver has fallen asleep, isn't paying attention, is intoxicated, is driving too fast, or loses control on wet or icy pavement. Carnegie Mellon University, in cooperation with the National Highway Traffic Safety Administration, is developing systems to prevent this type of crash. These countermeasure systems monitor the driver's performance and trigger an alarm when there is danger of a roadway departure crash. To facilitate development of these systems, we have modified a GM minivan provided to us by Delco Electronics. We have equipped this testbed vehicle, called Navlab 5, with a forward-looking video camera to see the road ahead, as well as a downward-looking camera to see the lane markers next to the vehicle. It has a satellite positioning system and a digital map for finding the vehicle's location on the road network. It has a video display for monitoring camera output and a laptop computer for sensor processing and driver interface control. There is also an electric motor on the steering wheel to provide the driver with tactile warnings, or to provide momentary steering control if necessary. All power is provided for onboard systems by the vehicle's battery through the cigarette lighter, making the test equipment extremely modular and portable. 3 warning systems are currently being developed and tested on Navlab 5. The first is a forward-looking lane departure warning system. 15 times per second, this system detects the road ahead in the video image and determines how the driver should be steering to stay on the road. This desired trajectory is shown in green. It compares this desired trajectory with the trajectory the vehicle is actually following. When the vehicle starts to depart the road, the desired and actual trajectories diverge. The system detects this divergence and triggers a warning signal. The warning consists of a visual message, an audible tone, and/or a tactile vibration of the steering wheel to alert the driver of the danger. If the driver does not respond to these warnings and the vehicle continues to leave the roadway, the system can trigger a momentary pulse to the steering wheel in the appropriate direction to begin the corrective maneuver. The data this system provides on the vehicle's lateral position and the driver's control responses can also be used to detect a drowsy or intoxicated driver before the driver's degraded state leads to a roadway departure situation. An alternative lane departure warning system we are developing uses a side-mounted, downward-looking video camera to monitor the vehicle's position in the lane. This system detects when the vehicle starts to depart from its lane and triggers a visual, audible, or tactile alarm to warn the driver of the danger. Both the forward and the downward-looking lane departure countermeasures can provide early warnings to help prevent many runoff road crashes, particularly those involving drowsy, inattentive, or intoxicated drivers. Another frequent cause of runoff road crashes is excessive vehicle speed, particularly on curves and under icy or wet roadway conditions. We are developing and testing a third countermeasure system to prevent this type of accident. This system uses satellite positioning and a digital map to locate the vehicle's position on the network of roads. When the vehicle approaches a curve, the system compares the safe speed for traversing the curve under the current conditions with the vehicle's current velocity. If the current velocity exceeds the safe velocity for the curve, the system triggers an audible or tactile warning to alert the driver to the danger. While still under development, our early results indicate that these runoff road crash countermeasures could prevent many of the nearly 3 million roadway departure crashes and 13,000 deaths that occur each year, potentially saving thousands of lives.